All right, moving right along, section 5 is on direct variation. We've done direct variation in the past. Hopefully you remember. These are the type problems where your constant remains the same, like you babysit and charge $10 an hour. So that constant is 10. If you babysit 5 hours, you get $50, okay? Or if you're driving at a constant speed of 70 miles per hour on the interstate, you drive for 3 hours, you've gone 210 miles, okay? So with direct variation problems, your graphs are linear, they go through the origin, and you'll set them up as y equals kx. So again, you might want to read the book, look at their presentation, but let's dive into example 1. It says find an equation of direct variation where y varies directly as x. So you start out like that. You have to remember that direct variation are this setup. All right, so if one pair of values is y is 7 and x is 25, okay? So that means we want to find the constant under these conditions. So we write this out, we plug in the y, we're looking for the constant, we plug in the x. Okay, these things are standing next to each other, they're being multiplied. To solve for the k, whatever's beside the letter, that's what I'll divide by. So my k, in this case, is 7 over 25. Do not turn that into, you can turn it into a decimal, but you don't have to, okay? So when we found the constant, we're going to write the equation of variation under these conditions. So we say y equals 7/25 x. Or if you've turned it to a decimal, y equals 0.28 x. Either answer is fine. All right, so I want you to try this A and B. So stop the tape, do your work, and then check with mine. For A, I know it's direct variation, so I write y equals kx. I plug in the y, I plug in the x, these are multiplied, so I'm going to divide both sides by 12. This cancels, so 1k, this quotient would be 7, so now I use the 7 right here, y equals 7x. I'm writing the equation of variation under these conditions. Over here, y equals kx, y, x, okay? Whatever's beside the letter, that's what you divide both sides by. This cancels, these cancel, I get 5/8. Y equals 5/8 x, or I could turn that to a decimal. All right, so now with word problems, let's do example 2. Remember, these are direct variation. So the weight of an object, they call it J, okay, varies directly as the weight on Earth. So if it varies directly, then I know y equals kx. In this case, J is what's said first, times, or equals constant times what's said second. So an object that weighs 225 pounds on Earth, so that's the E, has a weight of 594 on Jupiter. So I want to find the constant under these conditions. J is this, E is this. So first of all, I'll be dividing 594 by 225, and apparently that's 2.64. Okay, so I'm going to write my equation of variation. Okay, so Jupiter is 2.64 times what Earth is. Now, I'm not quite finished because it says then, what is the weight on Jupiter of an object that weighs 115 on Earth? So, J will be 2.64 times 115 on Earth, and apparently that is 303.6. Okay? So again, try C and D. All right, so for C, the cost of operating a TV varies directly as the number of hours. So cost is constant times number of hours. Okay, so it said it costs $14 to operate a TV for 30 hours. Okay, or 30 days, sorry. So my constant is 14 over 30, which I reduced to 7/15. And I wrote cost is 7/15 times the number. I was supposed to find out for 1 day, so I plugged in 1, and 7/15 is approximately 47 cents. And then for 1 hour, I need there 24 hours in a day, so I divided that rate by 24 to get 2 cents. I believe I need to do 0.02, sorry about that, or 2 cents. So first answer is this, second answer is that. All right, for D, the weight V of an object on Venus varies directly as the weight on Earth. So V equals KE. If something weighs 106 on Venus, it weighs 120 on Earth. So I divided, I reduced, and then I made my equation. And then I'm supposed to plug in 150 for Earth to see what it would weigh on Venus. And I get that. All right, one more little section tomorrow, and we'll be done with chapter 12. Have a great day, everybody.